Hello, so today we're going to be talking about how to solve systems using the elimination method. So I believe that below I'm going to post the method that I use, or rather the notes for the steps, in the description box below. So take a look at that. If you're currently in my classroom, then you should have already taken the notes from the Google slide presentation before watching this video. This video is going to be in two parts because it's very important to understand the concept of what we're doing first and then be able to apply it to more difficult and more advanced problems that will be occurring in part two. Okay, so part one is going to be just the basics and then moving forward from there. So the first thing I want to do is just inspect my system and determine which one is going to be my target variable. So I'm going to make the x's my target variable because I noticed that right off the bat they are inverses. So this is negative 4x and this is positive 4x. So I know when I add them they are going to make 0, which makes them eliminate, right? And that's the idea of elimination, that I'm going to find the sum of the system by adding it together. And one set of variables is going to cancel out. So the set that will cancel out are the negative 4x and the positive 4x. So I don't really have to do anything else besides find the sum of the system. So I'm going to start by adding the system together. Negative 4x plus 4x disappears. It eliminates. Then negative 2y plus 8y is 6y. And negative 12 minus 24 is negative 36. Okay, so now after I found the sum of the system, I'm going to continue to solve. So that winds up meaning that I just have to divide by 6, and my y value is negative 6. Okay, so far all I have found in my xy coordinate is the y value. So I'm still trying to find x. So I haven't answered the question yet because it's asking me to solve the entire system, which means I need a point. So I only found one part. It's very easy to find the second part because I have two equations to choose from. I'm going to choose the second one, the 4x plus 8y equals negative 24. And now that I have an equation, and I have a value to that equation, I'm going to plug it in. So this would work if I chose the first equation. It doesn't matter which one you choose. If you want, a strategy you can use is to pick the one with the least amount of negatives or one with the least amount of coefficients in front of the variables. I mean, it's your choice. It doesn't matter which one you're going to plug into because the idea is that this point will make both equations true. So either one is going to work just fine. So I'm going to plug in y. So 8 times negative 6 equals negative 24. And once again, I have a solving problem. So all I have to do is multiply 8 times negative 6 and then solve, and I'll be able to determine what the x value is. So this winds up being 8 times negative 6 is negative 48, and I continue to solve this two-step problem. So I add 48 to both sides. I wind up with 4x equals positive 24. And then I divide everybody by 4, and my x value is 6. So the point 6, negative 6 is the solution to the system. Okay? So let's move on to the second example, because our x's don't always have to be our target variable, right? I can use the y's as well. So if I take a look at the next example, I have x minus y equals 11 and 2x plus y equals 19. So my target variable in this example is going to be the y's. And that's because one is negative y and the other is positive y. So when I find the sum, it will eliminate. It's going to make 0. So I'm going to just find the sum of the system. X plus 2x is 3x. Negative y plus y eliminates. And I wind up with 30. So now I have a solving problem. I have to divide by 3, and I wind up finding the x value first in this case. So this is why it doesn't necessarily matter which which set of variables you choose to eliminate, because sometimes when you eliminate x, you wind up finding a y first. But then when you eliminate y, you wind up finding an x first. So it doesn't matter as long as you understand that you need to find both, right? This is not my answer. X equals 10 is not the only answer. It has to be in point form. So now that I have an x value, I'm going to choose one of these equations to help me solve for y. So I'm going to pick the first equation here, and plug in the 10. So I'm going to plug in 10 minus y equals 11 and solve. Maybe you can do this by mental math, maybe you can't, that's fine. Either way, the solving is going to get you to the answer. So your answer is -1 for y. And here is the solution to our system, 10, -1. Okay, so now what happens if they don't automatically start as inverses? We're going to have to use one of the multiplication properties of equality or division property of equality to be able to answer this question. So, for example, here, I can choose either set, but sometimes there's an easier method, meaning it might be easier to eliminate x rather than y or y rather than x. So in this example, the x's seem like they are going to be the easiest because they're almost inverses. They're both 6x. However, one of them has to be negative for them to be an inverse, which means all I have to do is multiply by -1 to the entire equation, and I'm going to wind up with a -6x. So I am choosing to multiply the second equation by -1. So I'm going to draw an arrow to represent that I'm rewriting this in its equivalent form. The top equation I'm not changing, so I'm going to leave it as is. And the bottom equation I am multiplying by -1. I'm doing this because then I will wind up with -6x, because that's -1 times 6x. -1 times 4y is -4y. And -1 times -10 is +10. Once I do that, I will realize that now my x's are inverses, meaning now when I find the sum of the system, they will eliminate. So if I continue finding the sum, I wind up with -9y equals +9. Divide both sides by -9, and y is equal to -1. So the idea is I want something like this to happen. So in order to do that, I need to make them inverses. So whatever I have to multiply by to get that to happen is what I need to do. So that's why I chose -1, because that's going to convert 6x into -6x, and the rest I don't really care what happens to. I have to be accurate, of course, when I'm doing the multiplication, but this is going to figure itself out once you start solving. This part right here with the 6x and -6x has to happen so it can eliminate. So if I write my point over here, I have -1 for y, but I still need to find my x. So I'm going to choose one of my original equations to plug in -1. So I'm going to choose the top one this time. So 6x minus 5y equals -1. I'm going to plug in my y value. So 6x minus 5 times -1. I wind up with 6x plus 5 equals -1. I'm going to subtract both sides by 5. And then finally divide by 6. So x is also -1 in this example. So our answer is -1, -1. Okay, so let's take a look at the next example. If you want to pause and see if you can figure it out on your own, by all means do so, or just follow along. Okay, so for this example, the y's seem like they would be the best choice. Okay, so that means that one of them is going to have to become a negative. So just because I can, I'm going to decide to multiply the top equation this time by -1. So make sure you multiply the entire equation. So the top winds up being -7x minus 2y equals -24. Now, it would not matter if you multiplied the bottom equation by -1. You would literally come to the same answer, okay? It's just a preference as to which one you want to multiply in this example. So our target variable y is now an inverse. So that means that when I find the sum of the system, these are going to eliminate. -7x plus 8x is 1x. And I wind up with 6. And now all I have to do is divide by 1, or just realize that x is already equal to 6. And so that is the first part of our point. All we have to do now is find y. So I'm going to go back to my original, figure out which one I want to plug into, which, you know what, let's plug into the second. It literally does not matter. So I'm going to rewrite my second equation, and now I'm going to plug in 6 4x. So when I plug in, I wind up having to solve. 8 times 6 is 48. I'm going to subtract 48 from both sides. 2y equals negative 18. And divide both sides by 2 to get negative 9. So our answer is 6, negative 9. Okay, so I hope you enjoy. Thanks for watching A. Heisig Creation. Bye-bye.